The Sky recording live from Twitch TV, and we're kicking it back up. We got the game world in place. The Sky recording live from Twitch TV. I got my audio on still. Oops. There we go. Alright, so sorry about that. In fact, you can't even see my face. Oh. No prep today. That was my bad. There we go. So, going to continue on with our game world. We're almost done. There was one more piece to this that we missed, or I missed. Well, we missed. You didn't tell me about it, so I'm just going to add this test here. I'm going to duplicate that one. And so, entity from world point with footprint offset. And so this, basically we're doing our footprint as if it was 0, 0. We want to offset the footprint, let's say 5 and 10, or 19. So that if our footprint is not really where our model is, or I don't know, for whatever reason, you decide to locate your footprint in a different spot, this is ready for you. So now we're going to see here, okay, with game out we're pointing 8347. Want to make sure that this one's still not found. I want to make sure that if we want to do something a bit closer, so if I do 83, it should actually miss it because it's actually offset. Actually, let's try 84. We can actually go as high as 85. So that should miss it, and this should also miss it as well by 340, 350. Because 357 is where it starts. So that one should assert null. And then if we do 100 and 360, we should hit it. So let's do it. So how you guys doing? Hopefully you guys are learning a lot, and hope this is making sense. If you guys have any questions, I had someone message me about setting up IntelliJ with HAX. I'll get that working on that. I was working on it last night, and I was trying to do it in Windows, but with running the video recording software, it was not pleased about it. So I have to go back and do that again, which is a bummer. But so what we're going to do is we're going to take our rect, so rectangle. We got our footprint rectangle. So we're going to actually add our footprint rect x and our footprint y. And that should do it. There we go. So we got that into place. Can never have enough tests. One more thing we can do is test should return null if passing null world point to bit item at. So we're going to set up pretty much the same way and trim out what we don't need. So we for sure don't need that. And this is null. I'm going to pass in null. There we go. Alright, so it crashed. And that's a failure in this case. So I'm going to say if world point is equal to null, return. Done deal. Okay, so did I miss something? 137. Return null. There we go. So we're getting closer to our game world getting set up, and our game world is maybe slightly a misnomer. I mean, it's not going to be so much of the world as it's just going to be the objects sitting in our world. our trees, our rocks, our happy little lakes and things. It's anything that like can pick up some sort of collision detection. That's good. That's going to be our world. The terrain, the place in which the units can walk around, that's just the terrain. That's just sort of art in this respect. So let's see where we're at here. So we got our game world. We need a couple of things to happen before we can get back to our game. Our playground is we need to implement our entity factory. So we're going to create a, should we call it, we'll just call it type entity factory. Type resolved. Yeah, that'll do for now. In fact, it's probably going to work better not in the 2D sense, so let's take that out. Doesn't really have any knowledge of whether it's 2D or 3D, so we're just gonna keep it on the top level. And there we go. So what we need is to set the display node, import, and there we go. Return null. And that's it for now. So let's go over here and set up our test. Run a unit. Create. Date. World dot type resolved entity factory test. Type resolved entity factory test. So what this is going to do is we're going to actually use this, and this is going to be very our game specific, or this game specific. And so I do have a vision for the game. I just haven't been able to spend time doing too much documentation, but coming soon, coming soon. Isn't that the word of the day? Coming soon. So we've got a bit of game engine to build before we have a bit of game to build. So, but it's coming along. I'm happy with the progress, that's for sure. So, entity factory. Oh, I don't need that score. This is an entity factory. And do we need anything else? Oh, we need the object creator. Entity factory init. And there's another thing too. I remember I don't know if you remember me mentioning, is created an object creator so that we have control of the creation of the objects and also the destruction of our objects. This also makes our unit testing heaps easier. So we can control when something gets created, we can avoid any side effects and things like that. So and just makes everything easier to test, and this is what we're trying to achieve here, is testability. Stability and testability. That's my favorite abilities. If I was a wizard, those would be my abilities. Testability. That's the worst joke ever. So, object factory. Object factory. Oh, object creator. Oops. Alright. Alright. So, we got our object creator in place, set our entity factory, and we always set our dependencies before we call init. That's actually how the framework works, so that we have our dependencies injected before the before init gets called, and we can interact with our dependencies a lot easier at that point. Object creator. So, test should resolve. So we can do, there's a couple things we can set up here. So start with our tester. Should resolve type and return display associated with the type. So what that means is we're going to pass in a game object. Where are we at here? We're going to pass in a world entity, and we're going to have some sort of map lookup that's going to say if it's a type wizard, for example, we're going to create this wizard entity, basically entity display, and all that stuff will be sort of created that way. So this will actually probably turn into somewhat more of a strategy instead of a factory, and we'll get there as we sort of build things up. But I wanted to build some base level thing so that we can get back to our playground, and this will grow throughout the development of the game. So what we're going to do is we're just going to create a let's see here, we create wizard, why not? And this implements a game object. Yeah. Do we have one of these already? We have a mock game object. I'll just stick with the mock game object. So what we do is we're going to create var game object. Mock game object equals mock game object. And what we're going to do is we're going to get a display node. This is going to be entity factory. Create view for entity game object. So they get us a display. I'm going to search is not null. That would happen. Okay, so at this point, this will for sure fail because it's getting a null, because we're returning null no matter what. One thing I need to do is I'm actually going to create a public I'm trying to create, public var. We'll call it entity map. And so this is going to be a way for us to map, I think we're going to do class dynamic. So we're going to map a class to a class. Yeah, I don't know if that'll, I wonder why that's getting us strange. I know this is wrong, but I wonder why this is being unhelpful. Alright, let's see if it builds. May not be able to do exactly like that. Oops. Let's see if it builds. Unexpected comma. So I wonder if it just requires weird. Am I going crazy? Oh, this is what it is. Jeez, I am slightly crazy. Wait a minute. How did I miss that? Okay. Chatting too much. Okay, so the entity map will hold a map between class to class. Yeah, it won't let me do that, so I'll just do dynamic. I thought. Oh, I think I did an object map. I think that's what it is. I might just be able to look this up. Import hex ds object map. There we go. So now we've got our entity map, and so we need to be able to set, like, to map stuff. So say like public function map type to type. Kind of weird, but what we're going to do is we're going to pass in a type A, and it's going to map to type B. I think I could get away with doing a generic here. Dynamic. And so what this means is when we map a wizard or something like that, it'll create some sort of wizard object and some sort of display associated with it and get it all set up for us. And then when we actually instantiate it, we'll just create the type B, return it. It might be a little hard to kind of imagine right now, but that's the goal. So we're going to say entity map set type A to type B. Let's take the casing here. Okay, so in this case, we're going to say the entity factory map type to type. So I'm going to say mock game object. It's going to be mapped to a bitmap node, and that'll work. It can just be abstract, especially for a test. So now, our object creator will receive create instance on bitmap node, and it's going to return a ret node, bitmap node, mock bitmap node. And then I think we're going to actually change this to, it's going to return a mock display node container. It doesn't have to enforce the type. We just need to know that we're passing in a class. So when we get a bitmap node, we're going to get actually a mock display node container. So it's opaque from the entity factory's point of view. It doesn't need to know the difference that we're creating two different types. In fact, in more cases than not, it will be two different types. So what we're going to do is we call that, and then let's talk to our object creator, create instance, bitmap node, verify, and that should do it. And this should set up our, get us closer to doing the has no field bitmap node. To get closer to getting back to our playground. I don't know why this is saying has no field bitmap node. Weird. Has no field bitmap node. Should just be display node. Does it change anything? Weird. Weird, weird, weird. So dynamic. So that's not going to work. Cast any. That will probably cause it to crash because it's not. Okay, we'll see if that does what we wanted to do. So we're going to see if this is going to work out. So world entity, say we need to get the type. And I need to look up the HAX documentation on this one because I forget. HAX.org, and we're going to do our API documentation. Under type, and we're looking for get class. Get class. Get class, and we're going to pass in the world's entity. I think my IDE settings are weird. Let's solve that in a minute. So here we should get a type, and then we're going to go to the object creator, create instance, type, and this should give us our var return val dynamic. And this is going to return other val. So we're going to need to trace through this. Find out what the type that class is returning. So it's returning us mocked game object mocked. So it is not the same. Wrong class. Don't do that either. So let's go back to our test. I think this mock is going to be weird. So I think we can get away with just instanting a mocked game object. Mock game object does not have a constructor. I think I did this once before. Puts it, there it is, okay. So now, it is a mock game object, still returning null. Probably because our object creator got an instance of type. So, oh, we need to get our map first. So we're going to do map type. It's going to be class dynamic equals entity map get our world entity. So it gets our world entity and we give our mapped type to it. And so that's returning null. Let's see why. When we map the type, mock game object maps to bitmap node. Because we got this in the wrong order. Here, this gonna get class of world entity. Even I'm confusing myself. Type, and then our mapped type. And There we go. There we have it. So I wonder why this is not allowing me to do bitmap node. Let's see if it changes its mind. No, that's strange. It should allow me to do that. I think it's because it's an actual mock. So let's go back to any, which I don't know if it's actually testing anything at that point, but it's okay. We can actually assert. It's actually a better test anyways. Assert our equal our ret node is equal to our display, and that's a better test anyways. There we go. Okay. Test should return null if node type is found. Count. So we're going to have basically the same setup. Here is null, and we're just not going to map it. And that passes. So that's great. So we got those two set up. One last thing we want to do is we want to dispose view for entity. So what we're going to do is should dispose entity, and what we're going to do is we're going to set up this. So we created our view. Now we're going to talk to our entity factory and say dispose for entity. I'm going to pass in the world entity, which is our game object, and we're going to pass the display to it. And we need to make sure that our object creator disposes the display. Verify. And we're getting much closer now. Alright, so here, object creator, dispose instance, display. Done deal. Okay, so not much going on there. We're not going to do too much more with it until later when we start actually creating real life game objects. So now I want to set up our, we have one small thing to build. We're just going to kind of rough it in. Is we're going to create our wizard game object and game class. So we're just going to call this game entities. And we're going to create a, call it a wizard game object. And we're just going to rough it in. This is not long-term stuff, but you can see the direction I'm headed. And we'll call this the wizard display. Yes. Okay. What we're going to need to do is we're going to have this extend. Actually, I'm not sure if we need any of that. And this is why the other thing is going to turn into more of a strategy pattern. So we're just going to do extends bitmap node ca bitmap node. Look at the playground. It's essentially going to be this here. So on the init, we're going to need to set this stuff. Think about this. Basically all of this. So we're going to make sure this is async. Create wizard. This is going to be forward. So that's our callback. Async. Create wizard. It's going to be kind of hacky just because I want to get this in there, so we can start using our entity, start setting up our game objects. In fact, we might end up creating the strategy sooner because there's a interesting disconnect between the game object and the display at the moment. The game object is going to need to be somewhat aware of going to be somewhat aware of the display. Let me think through this. So let's just grab this now. We're going to need an animation controller, and we're going to need an object creator. We just need to add this child to itself. This doesn't extend bitmap as is going to be display. No container. What is it? Display. Display. Here we go. Sprite. That's what I thought it was. That's what I get for not trusting my own thoughts here. So yeah, the display and the game object are going to be somewhat coupled. But take care of that in a moment. So we need this stuff. Image, and we're going to need the object creator, and I think that's all we need to get this to work. Adding the child, creating the animation. We don't need this. We're going to take the animation controller. Oops, darn it. Take this. I'm going to make that there. It's private. Just thinking through, kind of playing around a little bit. It's also kind of a nice thing too, as you kind of play around with your APIs, is to sort of understand how it's going to interact. So image, and if you're happy with it. Like right now I'm kind of feeling it out, see if I'm actually going to like the way this flows. I'm just kind of feeling it out, making sure it works. It's good to sort of play play around with your APIs to see if it's too hard or if it's complicated or maybe it's too simple or if it's not robust enough. Like these are all the things you kind of want to work out. Well, at least I'm trying to work out just to make sure these are the things I want. So let's do this here. Where do we assign the frames? We assign it there. Ow. There we go. We have our frames, we have our bitmap. We create this. Our bitmap node will be this.x and this.y. Actually not. We don't even need that. So I think this gets us a wizard in place. And then we need to get this implemented. Got a lot of getters and setters. Dink. There we go. Let's fill this all up. I think we're missing, no, we got our new getter and setter. Darn it. Getting too excited or something. Function, public function, funcicon. There we have it, so we got all that in place. And what we need to do is okay. I think we got our world entity in place, so let's go to our injection settings. And we're going to create our game world created already. So we're going to create our entity factory. Let's see here. Type resolve entity factory. Object factory, create instance. Type resolved entity factory. And I'm going to map that value. Entity factory. This is going to be entity factory. Entity factory. And then we're going to take our entity factory entity factory map type to type. So we're going to map our wizard game object to our wizard display. So every time we pass it a wizard game object, we're going to get a wizard display. We have our game world. So now, one more thing, I want to check our game world. Do we actually add, when we add the item to the game world, add game object, world entity, and world point, we actually do add the display. Okay, so let's do this. Let's go to our playground, and we have our game world. We have a world point. We create a wizard, which we don't want anymore. We don't need any of that now. Okay. Extracting it out. We don't need this anymore either. Taking some functionality out, but that's okay. We don't need this anymore. So we're making this much more simple, I think, as we're growing out our world. So let's give it a world point 2D equals new world point 2D, and we're going to give it x and y. We're sticking it y and z. We have to create our wizard, so this is var wizard game object creator, create instance, wizard game object, and then our game world, add game object. It's going to be a wizard, and we're going to send a world point. So if everything is wired up correctly, we should see no change from before. Of course. The thing I always forget. And here we go. Nope. It's missing the super constructor. Call super. Is that on the wizard display? Super. I just blindly added this one. That doesn't make sense. And then in the playground, we have this is upset. And wizard display, we're missing our JSON. So it's import hacks.json. Alright, we're compiling. So hopefully it's kind of come together. I think hopefully everyone's understanding it. I'm excited about it. The vision is coming clearer to me now. I'm liking what I'm doing with this. So let's see how this turns out. And there it is. Okay, so, and it crashed. Okay, so let's put on a debugging hat. Let's go to our playground. Let's start at the top. We create our wizard with a world point. Trace wizard. Make sure that's in place. And then our game world 2D is, we should have both of those. Trace display. This set display. So trace display world entity world point entity. This should all, ooh, this could be a problem. So where is our wizard game object? Okay, so we're going to create a private static var gen ID, get ID, gen ID. This is going to be uint. It's going to start at 0. So, why is it? Yes, I can. Alright, so gen ID plus plus. It's just being weird. So ID plus plus. So ID equals batch. See if this gets us a little bit closer. Okay, so we get the wizard game object. It's in our playground, so we're getting this. Game world should not be null. What we do need, though, is we need to do our game world screen to world. So that makes better sense. Game world, it'll crash by then anyways, but game world 2D. Trace world entity. And then we're going to, let's double check here with our injection settings. We are using our type resolved entity factory. So let's make sure that type world entity type mapped type val. Oh, nice. And then playground line 80. This returns our world point. All right, let's see how this pans out. Reopen. So we get to game world 2D line 81. Okay, so I see the problem. I believe the entity factory is not being injected soon enough. So I'll take this right there. All right. Come on, new bike. Okay, we're getting closer. So it looks like it got to image wizard. I think it got to the display. Probably because we didn't call super net. A lot of little working pieces. But once they're all wired up, it works great. There we go. So, something slightly weird going on, but that's all fixable. But now we got all that in place, we can take out our debugging a little bit. don't need all this. Okay. Game World 2D. Take this out. Show builds again. Okay, so we had them being placed in a strange spot every time. I'm going to create the wizard game object and pass it a world point. I'm just going to run it again just to see if there's some sort of glaring clarity here. Make sure that we're actually passing X and Y. Aha! It's being translated twice. So we were picking the point and then picking a point again. That'll just be weird. So let's try this again. Curious. Okay, yeah. There we are. There's our wizards. They're back. And they're actually being placed in the world now. So that's pretty cool. One thing I don't like, if you see here, is every single time I click a wizard, it's creating a new image. And we're going to get around that. Of course, we're going to get around that. It's all planned out. But what's cool is we've got our wizards placing. Again, our playground is getting simpler. Outside of this, the terrain, it's 3 lines. It's all being managed with the engine now. That's kind of exciting. So now when as we're creating our games, we create our wizard game object and we pass it in and the magic completes. So one thing we can do is we'll just create a private variable last wizard. See if this will turn out. Last wizard, and that'll be a wizard game object. And if we right click, move last wizard to X and Y. So just to sort of play this out a little bit. Last wizard. We have here last wizard and last wizard. So now we're going to move our wizard around. And ooh, 985. Oh. It's hard to read the word last wizard and not think lizard. It's ridiculous, sorry. Alright, come on, new bike. So here's our world, and he's not moving. Come here, little guy. Alright. Why not? Oh, we're calling move item 2. Let's call the actual method that we want. And I think we may not have actually implemented this. No, we did. We did. Move item to set display location. There we go. So there he is, and we just move him around as expected. Drop another wizard, move him around. So that's cool. All right, things are coming together. So what we can do here for fun. Nah, don't have time. We'll do it tomorrow. Get status, get add test world type resolve entity test. Git commit added finished the game world, created, I would say started the entity factory, and what's the last thing we did? We updated our playground. There we are. Git push origin master origin git tag. Today's date is 2016 03 24 at 8:40 Pacific time. Git push origin. And there we go. All right. So we got our entity on the game now. So we're moving forward, and I'll see you guys tomorrow. Have a great afternoon. I'll be uploading this to YouTube, so ask questions there if you have any questions, and I'll see you guys again later.